Hi, friends. We have found ourselves at the end of Chapter 6. We're looking at Section 6.8, Systems of Inequalities. And I hope that you'll find this section to be pretty much like kind of a review with a little extra added twist to some of the stuff that we've done before. So let's take a look at our vocabulary. The first vocabulary word, or the only vocabulary word, is systems of inequalities. Basically, it's a set of two or more inequalities with the same variables. So what it would look like if you had a system of inequalities is something like this. You could have 2x plus 3y is greater than or equal to 2,000, and then x minus y is less than or equal to 5. Something like that. So it is a system of inequalities. A system, remember we had system of equations that we talked about earlier. Systems of inequalities are very similar. The thing is, we're going to concentrate as we look at this section on graphing, because that's really the best and only way you can really have a good idea of what a system of linear inequalities look like. So let's take a look at our first example. As I look at example 1, it says solve by graphing. And this is what we'll solve by graphing. So here is our system. We've got y is greater than negative 2x plus 1, and y is less than x plus 3. So we're talking about the same variables, and we're going to basically graph them on the same pair of coordinate axes. So the first thing I did is I drew a coordinate axis, and I'm going to graph each of these inequalities, right? So you guys remember how to graph inequalities? I'm going to make this my yellow inequality, this first guy, and the other one, I don't know, that looks really terrible. Let me think, maybe instead of doing that, I will just underline it in yellow. How about that? And then my other inequality, I'll call it the red one. All right, so let's start off with this yellow one first. Remember, when I have an inequality like this, I have to graph the related line. So the related line is y equals negative 2x plus 1 being the y-intercept, and the negative 2 being the slope. I go down 2 to the right 1, down 2 to the right 1, up 2 to the right 1, and this is going to be down 2 to the right 1. Did I do down 2 there? 1, 2. Yeah, okay. So that's going to be my line. And fortunately for me, I've got a handy dandy line maker here. And I'm going to graph this line ever so elegantly by doing like that. And notice that the line is dotted. The reason why the line is dotted, let me put it on like that. I guess that's all right. The reason why the line is dotted is because notice that in the yellow equation, or the yellow inequality rather, y is greater than, not equal to, not greater than or equal to. So you remember how we handled this before. We would like choose a test point, usually 0, 0, find that test point, figure out what we wanted to do. When we figure out what we want to do, in terms of plugging in a point, we see what happens. So sometimes we do 0, 0. If it works, then we shade that in. Remember all of that? And of course, I mentioned to you guys that I look at this and say y is greater than, where's greater than above, and I shade above. So either way you do it, if you use a test point, whatever, we're going to get that the solution to this is all up here, all above that line, and that line is not included, okay? So I'm trying to shade that in there. The next equation that we need to work with is the red one, so I'm going to go back and try to figure out a good way to graph that. And basically the only good thing I'm going to do is I'm going to do exactly what I did last time. I'm going to find the y-intercept, which is positive 3, and I'm going to graph it. So if positive 3 is my y-intercept, I put a dot there. My slope is positive 1, up 1 over 1, up 1 over 1, right? Down 1, back 1, down 1, back 1. And so this is basically what my graph is going to be. Notice this time it's going to be a solid line. So when I do my graph, I'm going to make sure that it's a beautiful red solid line. And I'm just having a little trouble here getting the right color. Okay, there we go. So I'm going to make sure it's this beautiful solid red line, and there we go. Got that nice red line. Where am I going to shade? Again, I can do a test point, but the reality is y is less than this line, therefore I'm talking about below. So I'm going to now shade below. Shading below this red line with this obviously really bold red, looks darker than I want it to be. Anyway, shading below this red line shows me that I have an overlap, and that means that there is a solution area. The solution area, let me see if I can use another color. The solution area is going to be the highlighted area in white. So I'm going to basically try to show you this all in here. Nope, that's not going to work. Okay, so this is a bit of overkill, but the area that I'm concerned about is the overlap, where the yellow and the red overlap, and that's where I'm putting all these stars, guys. So this area is where the solution is for this particular inequality, for this particular system of inequalities, okay? Let's go ahead and try another example. So here we have another one in example 2, but example 2 is decidedly going to be a specific example because it says no solution. So we're not going to get a solution for this. And we're going to go through the same process, and we'll see how sometimes we don't get a solution. So we're going to solve this system of inequalities by graphing. And to do that, we should probably get an x and y axis to graph. So the first thing we do anytime we're going to graph inequalities is we're going to think about the related equation. And so that's my little thought bubble down here with the related equations. So I'm really graphing 3x minus y is equal to 2. I'm really graphing 3x minus y is equal to negative 5. And sorry for all of this strange writing, all of this stuff is going to come up here. And so when I graph an inequality, or graph an equation rather, I like to solve for y and start my equation, right? And rewrite my equation. So with a little bit of manipulation, you guys would see that y, if we look at the first equation, let me go ahead and give it colors. So this one is going to be my yellow equation here. I'll underline that first one. So here's my yellow equation when I solve for y. So when I solve for y, I get that y is equal to a positive 3x minus 2. Okay, so I will move the y over here, move the 2 over there, and I get positive 3x minus 2. And if I call this one my red equation down here, when I solve for y within the red equation, I would get that y is equal to, let me get that off the screen. Sorry about that, people. Hopefully that'll be fine. Okay, so I get that y is equal to, move the y over, yeah, positive 3x plus 5. So my y-intercept of my red equation is going to be, so I'm just doing this one first, is going to be a positive 5, so 1, 2, 3, 4, 5. And my slope is going to be up 3 over 1, but we know that we can also do down 3 to the left 1. It's kind of like having a negative 3 over a negative 3, which gives you a positive 3, right? And I can go down 3 again and then back 1. So this is going to be that graph. I'm going to use my handy tool over here to graph this beautiful red equation, but I need to really honor the fact that this is not equal to, right? I don't have an equal to situation when I look at the, or do I? No, I don't have an equal to situation when I look at the inequality, so I'm going to have a dotted line. All right, so that's my dotted line for that situation. And which way am I going to shade? When I look at this, I need to go back to the, I guess that is kind of crazy. I need to go back to the original equation, my original inequality rather, and kind of figure out what, which way am I supposed to shade, because this is just the related equation. So if I were to go back still with the red equation, if I were to go back and manipulate this thing again, remember y would be on this side, the plus 5, the minus 5 would go over here and become a plus 5, and what the symbol that would be facing the y would be greater than everything else. So this is y is greater than, not equal to, but just greater than 3x plus 5. I hope that makes sense. Let me know if it doesn't. I'll definitely explain more clearer later. And so that tells me that I'm going to, I could again do a test point. I could have done a test point in these original equations here, but I'm going to do a test point, or I'm going to recognize that y is greater than means to shade above. So I'm shading above. I'm not going to use that highlighter. I think it got a little bit strange and confusing. So now that we've got that done, let's go ahead and graph our yellow equation, which will turn into our yellow inequality. Notice that this inequality is greater than or equal to, so I'm going to use a solid line. When I'm graphing this, I'm going to look over here. Y is equal to 3x minus 2. Negative 2 is the y-intercept, and then the slope is going to be up 3 over 1. Up 3 over 1. And already you guys see what's happening, right? You see that these lines, the related lines are parallel, and since they're parallel, they're not going to intersect. And then depending on how I shade it, if the shading doesn't intersect, then, there's not much to do. So let me go ahead and graph this. This is going to be a solid line, again, as we mentioned before, and I'm going to be graphing this solid line straight through these points. This should have been yellow. We'll try to do that again. That solid line should go straight through those points. There's a yellow. All right. And there we go. Something like that. Yeah, something like that. Something like that. All right. So now that we have that solid line going through those yellows, then we need to talk about where we're shading. Again, if we go back to this equation here and we think about it in terms of the inequality, I would have moved y over to this side so that the shape of the inequality that's pointing to it would be less than. And if that's hard to understand, please let me know. I'm happy to explain it to you. So y is actually less than all of this stuff if I were to manipulate that. And then what I'll do is recognize that y is less than. That means I'm shading below. And you guys see with a whole lot of talk that indeed they have no solution in common. There are no points that satisfy both this inequality and this one. And we saw it by graphing. Let's take a look at another example. Okay, so with this example, example 3, whole number solution. So we are kind of dealing with a real life situation or real life problem in reference to this solving inequalities or systems of inequalities. So we have a club that is selling shirts. They have only enough supplies to print 120 shirts. They will sell sweatshirts for $22 and t-shirts for $15 with a goal of at least $2,000 in sale. So the first thing that we need to do is to define the variable and write a solution or write a system of inequalities to represent this situation. So let's just focus on that part. So if we're going to define it, the variables that we have are, let's say, X for t-shirts, because we're selling t-shirts, and let X represent the number of t-shirts that needs to be sold, and then let's let Y represent the number of sweatshirts that will be sold, okay? So if we do that, let's see if we can come up with a nice system of inequalities. So the first thing, when I go back up to the problem, it says they only have enough supplies to print 120 shirts. That's 120 t-shirts or sweatshirts. So X plus Y must be less than or equal to 120. Because if you can only do 120, you cannot do more. You can do less, but you cannot do more. So it has to be less than or equal to. Hopefully that makes sense. The next thing we need to talk about is, oftentimes this happens with systems of inequalities. You need to talk about the money. And oftentimes there's a money equation or a cost or a revenue equation that's related. They will sell sweatshirts. Remember, sweatshirts were Y. They will sell sweatshirts for $22 and they will sell t-shirts for $15 a piece. So if I'm selling, if X refers to the number of t-shirts, then I'm getting $15 for each t-shirt. So my equation is going to be 15X plus, again, $22 for each sweatshirt, and Y being the sweatshirts, I'm going to get 22Y. And that money, the revenue, the money that I'm bringing in, must reach a goal of at least $2,000. Do I want more than $2,000? Cool. Do I want less than $2,000? Absolutely not. So this must be greater than or equal to $2,000 to deal with the fact that that is the least amount that they want. So here are the two inequalities that we've come up with. So with those two inequalities, our next step is to graph the system, which we've done several times. So here's the graph. We're going to graph each inequality and we're going to display it on an XY plane. So here you can see my graph, and I know it's pretty hard to tell what's going on, but I tried to color coordinate it. So if I graph this first inequality, I'm going to be graphing this line here from 120 to 120 shading down. And if I graph this one, again using the X and Y intercepts, I'm going to be here at about 90.9 and down here at approximately 133.3, and I'm going to shade upwards because that's what my inequality tells me. So as I see how this applies to the problem, I see that this little sliver is my solution. 0, 120 is a possible solution, and 45,